Oh, let's see. Just 1, 2. Yeah, we're live. Good morning, everybody. Hello, Edison Carter. How are you? Well, it still hasn't uh, completely settled down. It is oscillating between. Let me move this yellow circle I've got. I was marking the extremes of the oscillation. It's still moving somewhere between like maybe 250 and 270, 271. So yeah, it takes a very, very long time to get one of these things to come to a stable position like we had at the start of the stream last night. And I haven't moved the white circle, or at least I don't think I did. If I did, it was purely accidental. That white circle is where we were last night. Uh, this wire has done what I've seen some others that were prone to drifting do, and those got discarded pretty quickly because you couldn't get them to come back to the same resting point when you went back to the equivalent condition. And this is exactly the way we started last night. We got the big balls in the neutral position, and that red dot has drifted almost 80 millimeters upscale. So that's the reason why this thing is unusable in terms of making any measurements of the gravitational constant. Doesn't stop us from using it to observe the effects of gravitational attraction. We can certainly see that. That's not a problem. We just we can't depend on the data that would come from it. So it's still drifting down a little bit. Let's see. I want to see what the extreme points actually are before we do anything. This is what happens with some of these wires. And I don't know why. I'm not a metallurgist at all. I know that over time they seem to, they will straighten out over time, I believe. But that length of time it takes them to stop doing this could be excessive. You go back and read the information that got published by the National Bureau of Standards. They built a Cavendish type device, and a very accurate one back in the 1930s. Actually, 1930 I think was the first time. And they ran it twice. They ran it once then, and they ran it again in 1942. If you read their report, they say that it took them 3 months to get the wire to settle down. So I'm not about to let this thing sit here for 3 damn months. The steel wires start behaving pretty well after a few days. This beryllium copper, being a springy material like it is, just isn't doing it. So, hello, Judy Bassett. How are you? Elmix, what's up, buddy? No, it's not April Fool's. Well, it is April Fool's, but this is not a joke. I'm just showing you. I just wanted to show everybody one of the kind of characteristic this particular wire has that makes me want to take it out and go in a different direction. That white circle is where we started last night, and it was rock steady down there. We sat here and watched it for an hour, and it didn't move more than a millimeter or so one way or the other. But after putting it through some rapid and pretty violent vibrations, oscillations last night, I came back in today some 12 hours later, and the purple circle and the yellow circle are the points between which the torsion balance is oscillating right now. So you can see there's been a huge shift, a huge drift in that 0 point, or that resting point. So, whoops, let me not move the wrong thing here. Sorry, over in OBS, I'm moving my little markers around. So, and Judy Bassett for €7. Thank you, ma'am. I appreciate that very much. Certainly do. Feral Cat, morning. Discord's up and running if anybody wants to drop in, or at least I think it's running correctly. You can see from this, though, how if we, the oscillation, I guess you got to take my word for it that purple circle was the top of it. Because that happened before we ever started the stream here. But assuming the yellow circle and the purple circle are the extremes of that damped oscillation. Obviously, the resting point is somewhere right in the middle there, or very close to the middle. And that's the way Cavendish collected his data. He didn't sit around for days waiting on the damn thing to become rock steady. That's the last thing you want to do, because every wire is going to drift to some extent. And if you stretch these tests out over a period of days, you're going to have no idea what you've got in terms of total actual displacement of the torsion balance. And if you don't know that, then you don't know what G is. So those are the issues. Yeah, and Feral Cat, I have not changed the wire out yet. I wanted to just do one last sort of quick live stream, just to show everybody what can happen with these things when you get wires that want to drift a lot like this one does. And if we take a look at that right now, last night we were at, when we started, 180, about 187 and a half was the steady resting point. And if I just try to eyeball average this, we go from 187 and a half to right now it's about 261. So what's the difference in that? 261 minus 187.5, 73 millimeters of change in that set point, in that 0 point, over the course of 15 hours. Well, the total expected deflection is around 70 millimeters. So this is more, there's more drift right now than there is predicted deflection from moving balls from one extreme position to the other. And that's the reason I'm going to change the wire out. We're going to go back to a steel wire that behaves a little better than this. I listened to some of last night's stream, and I have to apologize for the sound of this damn microphone. I see I got what I paid for. I think I spent 20 bucks on this thing. Should have spent 40 bucks and bought a real microphone. This thing's garbage. Hello, Christiane. Good morning. How are you? Or good afternoon for you, I suppose. Oh, just following up on last night's live stream. This is not going to go on very long. I'm going to let this thing oscillate back up to the center of that purple circle. That may take another 5 or 6 minutes, 6 or 8 minutes, something like that. And then just for one final demonstration of the effects of gravitational attraction, I think we'll make the red laser dot move downscale. In other words, make the bar rotate counterclockwise. Hello, Paul. Paul Witten, welcome. No, the size of the masses really won't have any effect on it. Mr. Andrade, good morning. Mark 10, good afternoon to you, sir. Afternoon, evening, morning, wherever you are. Hello, hello. Got 20 people watching. That's great. Glad everybody's around. Let me look over here on OBS and see where we're at. It's only back up to about 26, but it is moving, so. I believe I built this torsion balance 2 weeks ago today. I'm pretty sure that's right. So if this thing hadn't stabilized any better than this in a period of 2 weeks, we don't have enough time. And I will not sit here for the next 3 months hoping it's going to get better. Hope is not a good game plan. But I've got a piece of 0.007 guitar string. And I preconditioned it, and by preconditioning what I mean is I put a 28 ounce lead weight on one end of it, clamped it in the vise, and let it stretch for a couple of days, while at the same time occasionally giving it a spin and letting it spin unaided, just spin up and then reverse and spin back down and so forth. And doing that seems to help these things. I don't know. Maybe it's my imagination. But I've got that wire that's been preconditioned, so that's what I'm going to put back in here. Now, the thing I've got, the only thing that I'm a little concerned about with that wire is that this wire is 0.008 beryllium copper, and it's got a 23-minute period of oscillation. The 0.007 wire is actually going to have a slightly longer period of oscillation. Almost the same, but just because it's steel. And the modulus rigidity of steel is 150% or more of the beryllium copper modulus. And these 23-minute oscillation periods are difficult to deal with. To get through, 4 oscillations, you've got 2-hour time period in there. And I wish it were shorter than that. The alternative is to go back to 0.008 inch, and that cuts the oscillation down to about 15 minutes. So that may be where we end up. I don't know. I'm not going to say anything right now. I've been wanting to try that 7 thousandths wire for a while now, and I think this is the opportunity, and we're just going to go ahead and do it. If it doesn't work out well, it's no big deal. Just take it apart and put the 008 wire in there and go on. So 23 people watching. Thanks for showing up. I appreciate it. Yeah, FUD Muddin 008 is typically going to be about the smallest standard steel string you can find. This 007, let me see here. This is manufactured by D'Addario. I don't know who they are. I know they think a lot of that string. I paid about $6 for that thing, for a single string. Usually that's about what you pay for a whole damn set of strings. Let's see, Can't pronounce your name, Le Crossion, or whatever that, however you say your name. I apologize. I'm just an old Southern boy. We don't we we don't even speak English very well. Uh, Says if you need something really dense your ball for your balls, use Riley. Should work. Mr. Mr. Riley has been curiously missing since last night's stream. I've been expecting to hear something out of him, but apparently not. Ah, must have missed it. The red dot was even closer than I thought it was. It was down here somewhere. I missed the peak that time. You sort of gotta keep an eye on the timing. It's about 11 and a half minutes from a positive extreme to a negative extreme. So I wasn't doing a very good job of watching what was going on. I'll move the purple circle down a bit and we'll see. Yeah, FUDMUD, this is 007 from that Diodario place. But that's the only 007 string I was able to find. I don't know if a banjo string might be able to find a banjo G string or a fifth string that's smaller. I'm not sure. I know I had pretty good luck. That 007 Diodario string is what was on the other torsion balance, and it worked pretty well. So let's see. At 12 o'clock, we're 12:00, well, almost 12:02. I got our laser dot right down in the center of the yellow circle. Let's see if if it's drifting even further down. It may. But this is not abnormal, as Riley was trying to contend that these damn things have to sit perfectly still. No, they don't. Oscillation is a good thing. You like it. It's very predictable, period-wise. It won't change regardless of what the amplitude is. And it's easy to distinguish that rhythmic 23-minute oscillation from just random drift. Yep, it's drifting down. It's definitely drifting down scale. So we saw it a while ago hit this point. And now it's moved, whatever, 4 or 5 millimeters further to the left, further down the scale. So this is what you get into. Edison Carter, absolutely. That's exactly right. I've got a grandfather clock in there with a seconds pendulum in it. And once I got that thing calibrated, it gains or loses not more than about 10 seconds a month. It's amazingly accurate. And the same thing with this. It's a horizontal pendulum. It's simply getting its restoring force from the torque in that wire. And as long as the torsion constant of the wire doesn't change, the period of oscillation remains steady. It has to. AT2 Productions, what's up, man? How is Jared today? Sean Smith, howdy. Why are you not blue, Sean? See if we can fix that. Everybody gets to be moderator. I like it like that. Everybody gets to be moderator. Means nobody can pick on anybody else, but I can pick on everybody. Perfect. So let's see if this thing's gonna ever decide to bottom out down there. It will eventually. You can go crazy sitting here watching this thing. I promise you. Probably what's wrong with me now. I think we're very close to a point of maximum downscale deflection. I'll leave the yellow circle right there. Let's watch it for another couple of minutes. Hello, Clive. Yeah, I wish Sloppy would show up. He's been curiously missing in action this morning. Haven't heard a word out of him since the stream last night. But for those of you that have joined a little bit later, last night when we started this stream, the torsion balance had been sitting for days and days, and it was absolutely rock solid. It was, and that white circle is the mark, is the position that the laser was in. And the large masses were exactly like we've got them sitting right now in the neutral position. So we did the demonstration of gravitational attraction, and then we swapped places with the balls a couple of times and put this thing through a couple of violent oscillation cycles. And this morning you see what's happened to the position of the laser. Everything has drifted way upscale now. And this is the problem I've been alluding to when I put things in the community section. This is not just wild, uncontrolled movement of the torsion balance. It's still an oscillation, but it's got a drift associated with it, and it may drift upscale and it may drift downscale. And I've been watching this wire do this for 2 weeks now, and I've seen it happen with some of the other wire that I tried. That's why this is, to me, not a piece of wire that we're going to be able to use to gain any analytical data. We can get qualitative data from it, just like we did last night. There's no problem using something like this to show the effect of gravitational attraction. And that's what we did last night. We're going to do it again here in a minute, just to make sure Sloppy gets the point. First, I want to make sure it's gone downscale as far to the left as it wants to, and it seems to have stabilized. So because we're up on the upper end of the scale, and I'd really rather not run this thing off into the abyss on the right-hand end, I'm going to cause it to rotate counterclockwise if you're looking down on top of the torsion balance. And that means I need to put the lead weight on the right side closest to the camera. So I need to rotate those lead balls clockwise. And that should pull it down scale. Let's see if that really works. Hopefully that's the right direction. Should be. Yeah, S Thurston too. I think you're right. It's something like that uh, with that particular material. You know what we don't know, uh, and we'll never know as far as I can tell, is exactly what Cavendish did use. He just called it a silvered copper wire. Those are his exact words. But you have to know that in 1798, they didn't have methods of purifying copper like we can today. And today's copper is 99.9% pure copper. That's great for electrical use, and that's mainly what we use copper for anyway. But not so good for strength. And the problem I ran into was that by the time you get the cross-sectional area sufficient to get enough yield strength just to be able to support the weight of the torsion balance, you've increased that cross-section to the point that the torsion constant is way too large. Those things don't go hand in hand. The modulus of rigidity of copper is more than 50% that of the steel we've been using. On the other hand, the ultimate, or the yield strength of it is 15 or 20% of the steel. So that's the problem. Fudmutton says, can we use Galileo's simple pendulum formula? Yeah, I think so. Not sure why not. Uh-oh. What's going wrong here, Sloppy? Looks like that laser wants to move further to the left, doesn't it? Hang on, I got an idea. That might be gravity. Yeah, Clive. It's it's moving almost as if there's some sort of unknown force of attraction. Amazing, isn't it? You know, and it will do this 100% of the time, every time you do it. And J Bird Max says, how heavy are the lead weights? Well, the great big ones you see that you can see there are 22.03 kilograms each. So what is that, 47 or 48 pounds, something like that? Yeah, they're fairly heavy. They are surprisingly heavy when you go to pick one of them up. You're just not accustomed to picking up something that's only 6 inches in diameter that weighs 50 pounds. It's kind of hard to figure out how to get your fingers under it. And then hope that you actually don't get your fingers under it. That can hurt. And figuring out a way to hook those things up to this contraption single-handedly was quite a curiosity for a while. I finally realized that I could make a couple of little wooden platforms that they would sit on and just let them sit on the table and hook the rods to them that way and then pull the little platforms out from under them. It actually worked. So how far to the left is this thing gone now? I'm going to use another color. We've got a green marker up here. Let's put it down there. See which way this thing's going. All right, now we got little damn circles all over the place. this would be a half scale deflection. Full scale for this particular torsion balance would be about 70 millimeters. So we'd expect to see 35 millimeters difference here from the center point. And that would be an extreme, based on what we're looking at here, down around 205, something like that. But it probably goes beyond that point just simply because of the inertia of it. Another one of those Newton laws that flat earthers don't seem to understand. Very young. But how did you remove all the friction and torque? Go to your room. I've heard all that bullshit I'm going to listen to. 41 viewers. Hello, everybody. Thanks for joining in. I really think Anthony believes that torsion is some inherent built-in property. You can buy wire with however much torsion built into it you want. At least that's the way he's been talking. It just astounds me that somebody with his level of knowledge would have the absolute temerity to question people like Newton and Cavendish. My God. What is wrong with these people? Oops. Better go back over to OBS and move the green circle. And as I said, it's going to overshoot just because of inertia. Once you get this thing moving, Newton's first law decides to kick in. Oops. Moving the wrong thing. Be careful that I don't do that. Ah. Get back. All right. So I had a point I was about to make. I forgot what it was. Oh yeah, I know. If you looked at that crazy thing that, and Sleeping Warrior, bear in mind, has never confirmed that the device he claims he was testing was actually the one that John D., the guy that calls himself Dr. John D., presented on Randy's channel back last July. But assuming that it is, because Anthony Riley pretty well described the same thing with a little screw and a sharp screw sitting on a piece of glass at the top. In other words, no torsion element whatsoever. Well, the problem that Sleeping Warrior would have had, and is having, is that if that is the arrangement he's using, think about what we're watching right now. This torsion balance is applying torque to that wire, which is resisting that. And even though the laser right now is being pulled over to the left on the way we're looking at the screen, the torque in the wire is trying to pull it back to the center. Sleeping Warrior's gizmo, Dr. John D's idiotic gizmo, had no restoring force. That's the restoring force. And it has no such force. So what happens when you start that thing moving? Well, I can tell you what's going to happen. That torsion beam is just going to continue to rotate until the little balls in there bang into the side of the enclosure. That's what's going to happen. And that's exactly what he's been seeing. But he doesn't want to admit that they messed up. They totally screwed up when they built that thing. And the funny part about it is, all I can say is, I told you so. Because the day they premiered that thing on Randy's channel, I wrote a comment and sent Randy an email that said, hey, this is not going to work, and here's why. So, I don't know what to tell you guys. I know what to tell Anthony. Shut up, Anthony. Go fix your mess. Oh, FUD and then they mouse in a totally unpredictable way. You bet you they do. I've done that over and over again when I put a new wire in this thing, and it's almost unavoidable. You're gonna get it to swing to the point that the balls bounce off the inside of the case, and then all hell breaks loose. The only thing you can do at that point is just go in the house for about 2 or 3 hours until they settle down, because it goes crazy. "41 people watching. Hey, glad you guys showed up." Well, we're moving back upscale now. And again, this thing is it's set up in oscillation at this point. The torque in the wire is going to rotate the beam actually back through the resting point, which is probably around, I think maybe around 205. I said 205. No. Resting point wouldn't be 205. Resting point's much further upscale. Let me just take a crack at it. Maybe 220, somewhere in there. But this is going to go well past 220. Maybe I shouldn't say that too quickly. The way this wire drifts around. Let's just see. And S. Thurston, that's exactly right. Anything, uh, anything anywhere, you saw what happened. All it takes is raising and lowering this overhead door, or me going walking around that thing, to make it move just a little bit. And the problem that they've got with their arrangement is it's not going to move just a little bit. Once you start it moving, there's nothing to make it want to stop moving other than what little bit of air resistance you have on something that's moving that slowly, and the little bit of friction that you've got up at the top. So their experiment was doomed from the very beginning. Fudbutt says the ideal experiment would have an amplitude where the small balls do not hit the sides of the box due to restorative torsion from the suspension wire, and that's absolutely critical. You can make no sensible measurements of anything if those small balls in there ever make contact with the enclosure. You just can't do it. Super chat from Hugo Perez for $2. Hey, thanks, Hugo. I really appreciate it. Thank you, sir. Clive, they didn't understand how the Cavendish experiment works. I guarantee you they don't understand it. They clearly don't comprehend uh, the concept that this thing is a horizontal pendulum. They just don't get it. I can see what they were thinking. They were thinking, oh, well, we don't really care about making any measurements. We don't really care. We're not going to try to determine the density of the Earth, or we're not going to try to extract the gravitational constant. All we want to do is see the thing move. And that's as far as they thought. They just didn't think about how sensitive it has to be in order to be able to see the gravitational attraction, and how easy it is to have little disturbances in that case do what it did to them. And once it starts moving, there's nothing to stop it from moving. There's nothing resisting it saying, hey, don't do that, come back the other way for a minute. Hello, Dave, man. Yeah, you were here for a while last night, that's for sure. And Gorg Haynes, hello, good morning, afternoon, or wherever you are. Yeah, Clive, the Foucault pendulum is absolutely an example of where you want to have a frictionless pivot point. And actually, their their gizmo would be great for that. I'm not too wild about just the C-section, but if I wanted to build a proper Foucault pendulum, I would seriously think about a symmetric uh, box section at the top with a point contact, and the wire underneath it then can rotate and move in 3 axes. That would be ideal for that. I know I'm not describing it very well. Pink bunny suit. Watch this thing, it's going to go all the way into the yellow circle. I don't have another, I'm not going to move that white one. That was where we started. These two are sort of the extremes up there at the top end, even though this thing's drifting, so who knows where the real resting point is. It's in there somewhere or the other. Hello, Dora. Good afternoon to you. Oh yeah, you're right, Clive. We got to get clarity from Sloppy about which focal we're talking about here. What? Let's see, Robert Caslow. I have a hard time reading this computer out here. What's the lifetime of a torsion wire? I don't know. I don't know why it would have a lifetime. Can't think of any reason. Oh, the carrot characters. Edison Carter, thank you. You are correct. There. I'll take one. I'll take that. This one right here. No, you guys can't see this. I'll put it about where the center of the laser spot is. And JSS Tiger super chat for $5. When will Riley submit his report for peer review? That's a damn fine question. Thank you, sir. Thanks for the super chat. I really appreciate it. I'm sure it will be done in a timely fashion, just like his thesis or whatever that was to get flat Earth injected into the British school system. They're still waiting on anything out of that, aren't they? Pudman says, I believe Cassini added another term to Galileo's simple pendulum equation as it gains error with amplitude. It does. Once you go beyond some certain boundaries, and I'm not even really sure what those bounds are anymore. I haven't studied that in a long, long time. But we're nowhere close to it. Nowhere close to it at all. Howard Moore, yeah, Riley says what paper? Exactly. What paper? Yeah, what paper? The paper you fleeced money out of people to write. That's what paper. Richie says, may I ask when we see mass attracting mass, or have I missed it? And if the masses get attracted to each other, do they accelerate, like get faster and faster, like if we drop something? That's a good question. Those are good questions. Yes, you've sort of missed it. If you want to go back in the video, just back up. I think probably 30 minutes or so. Maybe somebody in the chat can tell you. But you'll see that the torsion balance was oscillating. The laser spot was going between that yellow circle and the purple circle. And now we move the masses to cause it to, the large masses to cause the torsion balance to rotate counterclockwise. In other words, now the oscillation is way down, it's to the left of the point it was oscillating before. But back to your question, no, it won't. It will accelerate with this torsion balance. It will accelerate to a point, but remember that the torsion wire is applying a restoring force, a force to the balance itself. So it will accelerate through about the first half of its motion, and then it begins to decelerate as the restoring force from the wire itself starts to slow it down. So it's not like dropping something. In fact, if you've ever seen a grandfather clock and watched the pendulum in the grandfather clock, how it accelerates as it goes down toward the bottom and then decelerates as it comes up the other side and then stops and reverses and does it the opposite direction. That's exactly what this thing does, except it's just horizontal. And instead of gravity being the restoring force is the torque in that torsion wire. I hope that made sense. Maybe it did, maybe it didn't. But you guys in the chat can help Reggie out, I'm sure. Did blue what, Howard? No, I ran out of little circles to put on the screen. The green circle was the furthest, the extreme point on the first oscillation. And the little caret that's sitting at about 237, just to the left of the yellow circle, that was the about the center point of the deflection, the extreme on the upscale side. So we'll see what's happening. It's still moving down scale slightly. It's actually not a bad way to do it. Instead of going from the extreme deflection one way and then switching the big lead balls to the opposite position, it's not really bad to go to the center point. You don't get such huge overshoots when you do that. And Cavendish did a number of his tests that way. You get just as accurate a measurement of, well, I should say that with a footnote. You get an accurate measurement of G doing it that way. It won't be as accurate because the total amount of deflection is not as great. So measurement error is a greater percentage. But it's still very usable data. So I'm going to take the green circle. I'm over watching this thing in OBS where I can manipulate this stuff. I'm going to keep the green circle centered around the laser spot, and we'll see what happens here. If the center point is up here, let's say the center before we moved the masses was up in this region, 240 to 265, so 252 and a half thereabouts would have been the center. And the predicted 252.5 minus about 35 millimeters would put the center point at around 217. So you would expect for the deflection from center to this east position that I've got the balls in right now, we would expect the center point to end up to around there, 217, somewhere in there. Got to let it oscillate a couple of times to find out. I'll hop back over on the YouTube chat and see what I'm missing. I think we're getting very close to a minimum here. Now, if you read the way Cavendish analyzed his data, he realized that letting one of these things sit for days before it ever becomes totally stationary is just not a practical way to conduct the experiment. Then you can introduce all sorts of other errors into your measurements, and you're not going to get an accurate measure of the gravitational constant, or in his case, Earth's density. So he came up with a scheme, and his idea was you measure 3 successive extremes of the oscillation. So think about a sine wave. You would measure the highest point, followed by the lowest point, followed by the next highest point. So you call that the first extreme, and then the low point is the second extreme, and then the next high point, which is actually one total period of oscillation, is the second high point. And what he said do, what Cavendish said do, is this: average the 2 high points together, because the second one will be a little bit less than the first one. It's a damped oscillation. And then take that average of those 2 high points and average them with the low point. And that gets you close to an accurate estimation of where the true resting point would end up being. And that's the technique he used throughout all of his measurements. It's kind of fun. You can see it and do it yourself. And he lists all of the extreme points, so you can go through there and do all the averaging and stuff and check his math if you want to. Edison Carter, I wish I could answer your question. I'm nowhere near that smart. Nowhere near. Eric says it's modeled as a second order differential equation. Yeah. Uh, I'm going to let you math guys fight all that stuff out. That's not me. Fudmutton says Cavendish was using more than just imperial units. He was going base 60. Yeah, apparently. 20ths of an inch. What an idiot. You know, I read that. I remember reading that for the first time a long, long, long time ago about Cavendish's scale and his vernier and marking the thing off in 20ths of an inch. And I thought, Jesus Christ, fella, that is the craziest thing I've ever heard. And then when I sat down and made up the scale and the vernier, it actually almost makes sense. Rachel, check my channel out. I've got a lot of videos on Cavendish sprinkled down through there, and it may help. Some of them will help you. In fact, the very last one where we were actually presented the results, the measurements, it's got a pretty good description of what goes on, and some pictures and stuff that you can look at. What type of webcam did Cavendish use? I don't know. I think it looked a lot like a piece of parchment and a quill pen myself. Okay, we're moving back up scale. Still. You can pretty much set your watch by it. 1,393 seconds is the oscillation period. Divided by 2. So the half period is 11.6 minutes. 11 minutes and 36 seconds. The trick to it is trying to figure out where the end of it is, where you can miss by 20 seconds easily. Trying to figure out where it's actually right at the center of the extreme. And really, the only way to get an accurate measurement of the oscillation period is to observe the thing over 6 or 8 or 10 total periods. And then a 20-second error becomes a 2-second error. I wasn't watching the clock. Anybody know what time that last minimum was set? Came up at? If you do know, type it in the chat. We'll see if we're right or not. But don't bet against me. I've done this before. 44 viewers. Hey guys, thanks for showing up. I appreciate it. This is very impromptu. I was thinking about tearing this thing apart and putting a new torsion wire in it, but then I thought, well, we did that last night, did that stream last night. Might as well just do it one more time, just for good measure. Be sure we have satisfied everybody's curiosity about whether mass actually is attracting mass or not. And if this doesn't convince you, I don't know what to say. Fudman says, I probably have better lacquer to treat the wood than Cavendish. Well, Cavendish probably would have used linseed oil. If they used anything, I doubt they would have used anything. I was just making mine look nice. But it serves the finish on it doesn't serve any purpose. In fact, that might have hurt me inadvertently. Putting a nice hard finish that's got tung oil and that has a little polyurethane in it. What I used is that combination. It's Minwax tung oil finish. It's got a slight amount of poly in it too. And I think when that stuff cured out, I ended up with a very highly electrically resistive finish sitting on that wood, which made it susceptible to electrostatic charge, which could be one of the problems that Dr. John D. and Sleeping Warrior ended up having. They made their box out of acrylic perspex, which is acrylic, and we all know how easily plastic can develop and hold a static electric charge. I said jokingly to somebody that if Sleeping Warrior were to grab the neighborhood cat and rub it against that damn plastic box, you could build up enough static charge to arc weld boilerplate. And that's about the truth. Edison wants to know if hardwoods would be less susceptible to humidity. They are. They pretty much. Any wood is going to be susceptible to moisture content. It's just unavoidable. But the way wood behaves, it expands across the grain, not with the grain. You think of wood like a bundle of straws. And so those straws can expand and contract in diameter, but their length doesn't change. This is reasonably hard wood too. This is African sapele, which is a type of mahogany. And I like making furniture out of it because uh, it doesn't react too violently to humidity changes. It does uh, shift around a little bit, but it's pretty easy to deal with. So what you make sure you do is you account for all of that. I didn't want the height of this thing changing, so the grain, that just tells you which direction the grain needs to be running. When you look at this box, it could expand in its width a little bit. But it's only, what, 3 5/8 inches or something like that. So from maximum to minimum, the expansion of that box itself wouldn't be more than maybe a 1/16 of an inch. And that's irrelevant anyway because the torsion balance is just hanging in there. It doesn't care how wide or narrow the box is as long as it doesn't run into it. As long as the balls inside don't hit it, and as long as we don't bang into it on the outside with the big ones. Because as soon as you do that, the damn balance goes crazy. You don't dare touch this thing. Alright, so while I was yapping, it did come to a maximum point of about 231. The minimum was about 201. Let's just average those just for the hell of it. 201 plus 231 divided by 216. And we said a minute ago that a good value, we'd get a good value for G if it ended up centered at about 217 and a half. So for just really rough eyeball, hold your thumb up, sort of measurements, it's pretty damn close. So let's see what else we got going on in the chat here. Edison Carter said, "Was your lumber pressure treated?" Oh no, no, no. I don't do pressure treated. That stuff's okay for building a deck out of, but not anything like this. The main framework is made out of southern yellow pine. The corner posts, I think, are Douglas fir, but they're not treated. And the enclosure, the cabinetry, is all African sapele. And Barry, I had an exterminator treat this for NASA termites. I realized that could be a cause of systematic error. So yes, all the NASA termites have been exterminated. Dave N says he's glad to hear I've got a dedicated ground. Yeah, using the ground system in your house electrical system is better than using nothing. But it's much better to have an actual earth ground for this thing. So that's the reason I stuck an 8-foot ground rod out there. Now I don't have any concern about it. Barry says, yeah, it makes it scientific. Yeah, it does, doesn't it? So if we use the Cavendish method, the green circle would be the first extreme. The little red caret would be the second extreme. And the next extreme here going to the left would be the third one. So we would average 201 with wherever it stops this time, and then average that with 231. And that would give us our predicted center point of oscillation, the resting point. Not going to do all that right now. Let's see, somebody gave me a time. 12:44. All right. So we should be coming up on an extreme if 12:44:36 was good. The extreme point's going to be at 8 minutes after, so about another minute and 15 seconds or so. I'll move the green circle. Okay, instead of 201, it looks like it's going to be about 208. So if we average 201 and 208, we get 204 and a half, and then average that with 231. And you get 217.75. Damn, amazing. Sleeping Warrior, I hope you're watching. And you can keep doing that. You can take, it doesn't have to just be 3 extremes. You can take 5 extremes or 4 extremes and just go in sets of 3. And certainly within 2.5 periods of oscillation, you can come very, very close to the resting point. Been able to show that time and again. TP Seeker wants to know if I've decided where this thing is going to go. I've actually had several institutions express interest, but uh, just as a matter of personal convenience, there's a pretty good likelihood that it's going to end up sitting down at the University of Tennessee here in Knoxville. It's easy for me to get there and get this thing down there. And although it's not my alma mater, it's certainly my youngest daughter has graduated there, so I don't feel like a total turncoat. And UT's got a good physics department. They're very keen on the idea of having this thing. And what I like is they're willing to use it they want to use it as a functional teaching aid, not just as a display off in the corner somewhere. We put too much work into this damn thing just to have it sit around. It ought to get used. It works, and it should get used. You're welcome, Richie. I like giving everybody spanners. That way nobody can pick on anybody. But we got a friendly crowd that comes here. When I do my streams, I don't think we ever have any issues out here. So that's great. Fud Button says if you pull a suspension wire using a micrometer to measure the wire at various positions, you might be surprised at the variation. No, I wouldn't be. It does vary. I've got a micrometer, and it will vary. I see that all the time when I put a different torsion wire in here. I can calculate the theoretical oscillation period. That's a straightforward, fairly easy calculation to do. But then you put the actual wire in, and you get a number that's not the same. Sometimes it comes out really, really close, but usually not. It'll be off by 5% one way or the other. And then you go and start measuring the wire itself, and then you understand what the problem is. Even though that thing says 0.007 inch, it might be 0.0068 or 0.0072. And in fact, it might be both of those numbers all in the same 3 feet of wire. There's definitely variation in it. So what do you think, guys? Have we adequately demonstrated that mass, in fact, does attract mass, and that we can use even a wire that's drifting around to obtain some reasonably good experimental data? Jane Doe for a super chat for $9.99. I don't think I've ever made it. I don't think I've ever made it one of your live streams. Here's a long overdue super chat. You've done an amazing job on this build. Thank you so much, Jane Doe. I really appreciate it. I really do. And Two Stroke for me says it's a very elegant experiment. Yes, it is. It's been an experiment that has fascinated me most of my life since I heard about this thing and read about it the first time, 50 years ago in college. This Cavendish guy knew his business for sure. The level of detail and the the lengths that he went to ensure that he was doing what scientific method tells us we ought to do. And that's a good segue into a tirade about that bullshit. The scientific method is simply any method you care to use that stops you from thinking something is true that isn't true, or makes you believe something isn't true that actually is true. That's really what the scientific method's all about. And any way you go about doing it that will achieve those two goals is perfect. Cavendish nailed it. Cavendish absolutely nailed it. It's been the prototype in my mind for how scientific experimentation really needs to be done. If you're unclear about what should happen, just read. You don't have to read all the facts and figures on in Cavendish's paper, but read through his thoughts and the systematic approach he took to things, and the amount of planning that went into it. That's what separates this sort of experiment from some idiot with a glass of salt water and a damn egg. Barry on for $5. Thank you, Barry. This has convinced me that the earth is flat. And the balls seem to be moving because of perspective. Also, happy April 1st. Yep. Thank you so much for that. Two Stroke for me says we did something similar back in college 35 years ago. It wasn't very precise, but it showed an attractive force. And that's true to this day. I think maybe one of the more popular, what should we call it, store-bought Cavendish experiments is made by a company by the name of Pasco. You can look them up online. Pasco makes those things. They're notorious for being finicky and hard to set up. I think that may have been the same thing that I used back in my college days. Can't really remember now, but just looking at what I see today, it seems pretty similar. But those things won't get within better than about plus or minus 20%. And they tell you that up front. That's okay. It still shows the effect, and it at least introduces the physics students to all of the theory that's involved in it. And it's pretty interesting. Go through my video where I explain how the calculations are done. You see, it's pretty straightforward. It all makes sense. I've thought about once this is over with and I get this thing out of here, I might make a little demonstration rig about torsion balances and build one that would have enough restoring force that we could actually be able to measure it with a scale. And, it's all the same. It's all the same theory and the same formula. And that way we could run through it and verify that the stuff really absolutely works the way we say it does. Fudman says that Fisher-Price toy he's talking about, Pasco, cost over $1,000. Yes, it does. It costs more than that. I think the cheapest I've seen is around 1,800, and then you don't have everything. You need some accessories, lasers, and things I think are separate. The Elmix says, funny how it looks like Newton is still usable despite first thinking there are two gravities. Yeah, that just drives me berserk. Everything about what they say when it comes to gravity makes me angry, I think. Einstein didn't supersede Newton. Even Einstein said he didn't supersede Newton, for God's sakes. There aren't two gravities, there's one gravity. And what idiot would want to use the field equations on a day-to-day basis to calculate routine stuff when you know you're not going to get a different answer? Let's see what this thing's doing. I think I probably missed that extreme. That's okay. Go back and pull up the. Well, I'll go back and pull up the video later and look at it and run through a few calculations and just see what it's telling me. I don't consider what we've done today much of an analytical measurement of anything. It's just more for demonstration purposes, that's all. But qualitatively, it's fine. Yep, I had to run. Mrs. Blue needed something there. In fact, I'm gonna have to probably shut this down shortly. Let's see what it says here. Yeah, we've been live. Good Lord, I've been running my mouth for an hour and 50 minutes already. So, anybody in the chat got anything before I leave? Again, I want to thank everybody that showed up, and I apologize for these impromptu live streams of mine. As we move on and do a little more testing, I'll try to get this to be a little more structured too, so that you guys can have some forewarning. Elmick says thanks for the stream. No, again, thank you guys for being here. And thanks to everybody for the support. Mark 10 for what is it? What we got there? £5. Yeah, great. I really appreciate it. Kudos for showing the April Fools how it's really done. Yeah. Yeah, we don't need April Fool jokes as long as we got Sleeping Warrior around. Judy, you betcha. Thanks for being here. And yes, two-stroke for me, this is a beryllium copper wire. It's easy to work with, and I don't like the way it behaves at all. It's just been a pain in the ass for the last 2 weeks, so uh, I'll probably take this thing apart tomorrow and put the steel wire in it. We'll play with that for a while and see what we get. I'd like to get a few more confirming measurements. I don't need another 14 tests or 16 tests, but get a few more with these larger masses in different oscillation periods, just to confirm the work that we've already done. I think that would be good to have. And then we'll move on to testing some different material. And that should be fun. Thanks, Footman. I appreciate it. I have tried. You guys have supported it, and I hope everybody thinks they got their money's worth. But the support has just been excellent. Really has been. Hey, Bendy Light, shout out to you, sir. Super chat for $4.99. Great job on this project, Blue. Glad it will be used to continue to educate people. I wonder if any unis are interested in Riley's experiment. I'll tell you what, I'll go out on the limb and say, hell no. Not a chance. Not a chance. Let's see where we are time-wise. Yeah, it looks like we've been live for about an hour and 56 minutes. 58, 57 minutes, something like that now, so. Well, I'm going to get out of here, guys. Thanks for coming. We'll be doing some more of these in the weeks to come, so. And as I said, I'll try to make it a little more structured than it has been. It's been a little bit haphazard, so my apologies for that, but you guys take care. See you later.